morning, geometry students. This is Mrs. Myers. We are doing lessons 9/10 today, which is the first of 2 lessons on finding areas of figures within the coordinate plane. So we already talked about how to find areas of figures back in Mod 3. So now we're basically just going to put this together with what we've been doing so far in Mod 4. All right, so the first is just a quick review of finding an area of a rectangle and a triangle. So hopefully we all remember that the area formula for a rectangle is length times width, and that the area formula for a triangle is 1/2 base times height, where the base and the height always need to be perpendicular to each other. So what we're going to do for each of these, because the length and the width and the base and the height are vertical or horizontal segments, is we're literally just going to count units. Okay, and we're going to need to be able to do that throughout this lesson here. So the length, for example, we can say is 1, 2, 3 units long. Okay, times the width is 1, 2 units long. So this area would be 6, and then of course that would be square units or units squared. Okay, the area of the triangle, 1/2 base times height. So notice that we have a base and a height here because their vertical and horizontal segments would form a right angle. So base 2 units long, height 3 units long, and 1/2 of 2 times 3 would be just 3, and again square units or units squared. Okay, so we absolutely need to know how to do that for the lesson. So moving right along to the meat of the lesson here is we've got one of 2 different methods that we're going to use to find areas of figures that would not necessarily be quite this easy here, like just a basic rectangle or triangle that is already a right triangle. So you've got 3 vertices here that form a triangular region. Okay, so let's plot them. We got 0, 0, which is point O. We get A, which is 5, 2. And we got B, which is 3, 4. Okay, so the thing is here is we've got ourselves the triangle that, we can't use this 1/2 base times height formula for, because neither of these 2 sides, none of these 2 sides have a right angle form. Now I could prove that there's no right angle here if I found the slopes of each of the sides, and I would see that no pair of the 2 slopes would be negative reciprocal values to each other. Okay, I'm not going to take the time to do that. Just take my word for it that there's no right angle here. Okay, so again, we can't use this formula. Okay, we can only use that formula when we have 2 sides that form a right angle. And then, it's easiest to use it when it's a vertical and a horizontal side that form the right angle, because then you could just count boxes, okay? So again, we're going to learn one of 2 methods here. First is going to be called the decomposition method. This is a lovely catchphrase that helps you to remember what the decomposition method is, which is box it in, okay? So what we're going to do is we're going to put a box around this figure, and we would like it to go through the vertices if possible. So we want the smallest box possible that will contain this figure. So I'm going to do this box right in here to contain this figure, okay? So now if I find the area of that entire box, which is really a rectangle, okay, so I find the area of the rectangle, which is found by doing length times width, and that is 1, 2, 3, 4 for example, the width, okay, and then 1, 2, 3, 4, 5, okay, for the length, for example. So this area is 20 square units. Okay, what I would want to do from the area of that rectangle is I would want to subtract away the areas of those 3 pieces. Okay, so we already learned about this again back in Mod 3, right? Okay, so we've got this figure of the triangle within the box now, and we're going to take away the extra pieces on the outsides. What's super nice about that is that they're all right triangles. Okay, so I'm going to find the areas of those 3 right triangles. Now what I suggest you do is stay nice and organized. So I'm going to put numbers here, okay, so that off to the side of the paper I can show what it is that I'm doing. So I want to find the areas of right triangles 1, 2, 3, and 4. So of course the area of a triangle, okay, let me actually write the word triangle here, is 1/2 base times height, as long as it's a right triangle and I easily have a vertical and a horizontal side to find the lengths of. Okay, so I could just find that. So the area of triangle 1 is 1/2 of, and that would be a base of 4 and a height of 3. or base of 3 and a height of 4, but it doesn't matter because 4 times 3 is 12 and half of 12 is 6. Okay, I'm going to find the area of triangle 2, which is the same exact formula, but now it's 1, 2, and 1, 2. So again, it doesn't really matter how we put that in because 2 times 2 is 4 and half of 4 is 2. And I'm going to find the area of triangle 3, and that is 2 by 5. All right, so now that I've found all those areas, so 2 times 5 is 10, half of 10 is 5, I'm going to add them up. All right, so 6, 2, 5, that adds to be, of course, 13. And then to find the area of a given triangle, I'm going to just do the 20 minus 13, which is leaving me with 7 square units, or units squared. All right. So that's our decomposition method. Okay, let's use the decomposition method one more time. Okay, this time with a figure that's not a triangle. Notice that there are 1, 2, 3, 4 sides, so quadrilateral ABCD here. Okay, notice it gives you the vertices, the coordinates here. Okay, so A is the 1, 1, B is 6, 2, C is 5, 4, and D is the 2, 5. So we are going to use the decomposition method. So we're going to box it in. So I'm going to try to contain as many vertices as I can and have the smallest box possible. So if I draw a box like this, that'll do it. Okay, so let's find the area of this entire box here, and that would be 1, 2, 3, 4, 5 units there, and then 1, 2, 3, 4 units there. Okay, so I'm going to find the area of our box of our rectangle, which is just length times width, and that's again the 4 times the 5, and that's the 20. All right, so now I want to subtract away from that piece, and then this piece. Now the thing about this piece though is I need to break this up a little bit more. Okay, so I'm going to just take that little corner piece away there. That way I've got this right triangle, that right triangle, and then that one little square unit. Okay, so I'm going to put that as a 1, that's a 2, that's a 3, that's a 4, and that's a 5. Okay, so of course the area of a triangle always, when it's a right triangle, okay, is 1/2 base times height. You can easily use that. So let's start with area triangle 1. So that is a 4 by 1 triangle. So that's 2 square units. And then the area of triangle 2, that's right here, that's 5 by 1, right? So that is 2.5. And then the area, of triangle 3, and that is a 1, 2 by 1. So that is only 1 square unit. The area of triangle 4 is 1, 2, 3 by 1. So that is 1.5 square units. And then finally, I've got the area of this square, which is area number 5, and that's just 1 square unit, right? So when I put all that together, when I add all that together, so 2, the 2.5, the 1, the 1.5, and then the 1, okay, I get 8. Okay, so now I'm just going to take this whole unit square, 20 square units, the entire box. I'm going to subtract away the 8 square units, which is all those extra pieces on the outside, and I get myself 12 units squared, or square units, for my figure. All right, so hopefully you understand decomposition method there, and now let's move on to what we call composition method. So whereas the decomposition method is put a box around it and take away the outside pieces, composition method is to break it up into, well, areas that you can easily find the number of square units for. So what I always suggest to students when you break this up is to try to just do rectangles and right triangles. So starting at the vertices, okay, if I take, for example, this vertex and I go straight down, now I'm not going to go straight down all the way, because if I do, then I'm going to intersect this side here at a point where I don't really know if this is halfway, not halfway, so that's not going to give me an area that's easy to find. So what I'm going to do is I'm going to stop once I get to this vertex here, and I'm just going to go straight across, okay? Now I'm going to take this vertice down here and I'm going to go straight up to where I meet that horizontal side right there. See, because I know that this is a right triangle now. I know that this is a right triangle. Okay, I'm going to take this vertex here. I'm going to go straight across. Okay, so I know that this is a right triangle. I'm going to take this vertex and I'm going to go straight across to where I meet that vertical side, so horizontal, vertical. I know that that's a right angle. Then I'm going to take this vertex and I'm going to go straight down because I know that that would again be a right triangle. And then right in here, I've got two options. I can either just go straight across here or I can go straight down here. I think we're just going to go straight down. And I got myself the two rectangles. So just like I did before, okay, where I numbered everything, I'm going to number everything. So I got my right triangles. I got the 1, 2, 3, 4, 5. Right, I got all those right triangles. And then I got my two rectangles, which I'm going to number 6 and 7. All right, so let's find the areas of all those triangles first. So the area of a triangle is always 1/2 base times height. The area of a rectangle is always length times width. Remember, always write your formulas down. So let's do the triangles. So we've got triangle 1. All right, so that is 1, 2, 3 units by 1, 2, 3 units. So half of 3 times 3 is 4.5. Okay, area of triangle number 2. So that is a 1 by 2. So that is only 1 square unit. And then the area of, oh, I should be putting this backwards, triangle 3, sorry about that. So that is 1 square unit there, and 1, 2, 3, 4, 5, 6 square units there. Okay, so that is 3 square units. Number 4, so that's 1, 2 across, and 1, 2, 3 up. All right, so half of 2 times 3 is 3 square units. And then area of triangle 5, okay, and that is a 2 by 1. So that is only 1 square unit. All right, and then we've got our rectangles, okay, so area of rectangle number 6 is a 2 by 3. And then remember, that's just length times width, so now that's 6 square units there. And this area of rectangle number 7 is a 1 by 2. Okay, so now I'm going to just add all that together, right? So I've got my 6 and my 2. Let me just add that together here. That's 8. Okay, and I've got the 4.5, the 1, the 3, the 3, and the 1. So let's see, 3 and 3 and 1 is 6, 7, 8, 12 and a half. Okay, and then I'm just going to add the 12 and a half and the 8. So I get 20.5, and that is units squared or square units. Okay, and that is again what we call composition method. Okay, so composition method is when you break it up. Okay, and again, think about only breaking it up, in my opinion, into rectangles and right triangles. So use the vertices to start working inwards. Now you might think to break it up differently than what I've done here, which is totally fine, but you just want to make sure that you always break it up into rectangles and right triangles. Okay. And then there is the decomposition method, which is box it in. So let's put a box around it, find the area of the entire box, and then subtract away all the pieces around it, around the figure that are within the box, okay? All right, I hope this is understood by you all. There's a problem set to go along with this, and post your homework by the end of the day, please. So for those of you who are posting at like close to midnight, if you kind of, rein that in a little bit, maybe post it a little bit earlier, that would be great. And then, tomorrow I will post the answer key and I'll have you check it over. And also, there's a separate post on in Google Classroom about the Castle Learning Review that I have assigned, that is due on Monday of next week. That's a review of the first 4 lessons that were gone over in this module. So if you have questions on that and you would like to ask about them, please feel free to join me for Wednesday's Google Meet, and I will answer some questions for you then. All right, hope all is well. Goodbye, all.